material before the class as well as after the class. Okay, do it before the class. Just read ahead of me. Okay, you guys know what we talked about last week. Okay, so read ahead of me by a few sections or whatever you can afford. And in the class, if you have reviewed the material, you probably would have some questions like, okay, in section blah blah blah, in your module blah blah blah, I have a question. It's not really clear, what you meant by da 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 da. Okay, and you can bring that up in the class. When we get to that topic, bring it up in the class so I can further explain, what is maybe lacking in the class in the notes. After the class, it is also a good time to go back and review the material, as well as take a look at all the files that I capture, so that you can say, okay, Tech talked about this in the class. These are the steps to do something. Do I really understand why we have to do it that way? Okay, and since it's right after the class, chances are you still remember, you still retain a lot of the material, and you can still remember, okay, now I remember, we have to apply the inverse function instead of the function because we want to go back and say how this expression relates to all the other variables before the statement. Okay, so it's reinforcement after the class. So personally, I think it is very important to do all that stuff. Technically speaking, with a class like this, with 3 hours of lecture every week, students of this class is supposed to spend 3 additional hours outside of the lectures to review the material, do the homework, and stuff like that. So I think it is important to put in the time to do it. Is that okay? I don't want to be nagging, but since I'm now a parent, I have this bad habit of nagging all the time. Yes?
Can you put any more examples online of these, just so I can
Sure.
get practice?
Yeah, we can do that. Yep, I can put on more examples. And I also go through examples in the class as well. It's better for you to start with a new example so that you don't have a pre-exposure to the answer. Yep. Okay, any other questions? No other questions? Okay. So I just thought that I can, it's kind of neat that I can show you this. With this class, since it's a face-to-face class, I cannot drop people because of lack of activity online. I would, if I could, I would, but since I could not, it's a pity that I could not do that. It would be so easy too, because Moodle can sort by last access time. I just look at anyone with more than 7 days of inactivity, going to Socrates, and just drop people because of that. Okay? But I could not do that. I have to take roll in order to drop people from the face-to-face class. Okay, so now that we are done with assignment statements and the sequence, we'll move into conditional statements. In other words, if I give you the precondition of an entire conditional statement, can I derive the post-condition of the entire conditional statement? And in the notes, I guess, really should be showing you this. Where in the notes do we have all this stuff here? It is in module 46, the pre and post condition module, and we are now talking about conditional statements. So if you're reading the notes, this is the part that mentions, conditional statements. But I do not, read from my own notes, simply because, I don't like reading my own notes in the class. That would make it very boring. So what I would do is I would just type up the algorithm, and then we'll explain it. So we have if x is greater than y, then something. Then we have z gets x. Okay. Then we have else, and we have for z gets y. And then we have line 5 being and if. Okay, so from now on, I do not need to refer to my notes anymore. I would just basically work the entire thing out and type it up in the notes like this. This will be saved at the end of the class too. So when you log into Moodle next time, whatever I type here will be available. When you go to YouTube, you will actually get to see how this is all created with the audio captured at the same time. Okay, so there's a lot of stuff you can review. The material is all there. All right, this is a conditional statement, which is kind of, interesting. It's not an assignment, not just an assignment statement anymore. So with this type of statement, the first thing we want to do is really just to review and say, yes, go ahead.
I'm sure we covered this last week.
We did not cover this last week. This is new material.
No, we covered it without respect to the pre and post conditions. So we didn't do this, so we introduced that statement.
Okay. Are you referring to the conditional statement, or are you referring to the substitution and the forget?
No, the else statement.
We should have introduced that in the conditional statement module. No?
I don't know.
Okay. Do you remember pictures like this?
Yeah. We did
Yep.
loops.
Yep. And then we did loops, and then we are now at this point. Okay.
Opposed to precondition, right?
Yeah, this is in the this is conditional statements, but in the context of pre and post conditions. Yep. So we have talked about this already. We traced examples, because otherwise you would not have the multi-branch conditional statement homework assignment. But at this point, we are not going to trace it. We want to derive the pre and post. We want to derive the post condition from the precondition, but using the same type of statement. Okay. So with that, in that specific case, now remember, anything that I draw on the whiteboard, I cannot capture in the notes. Yes, I can using my cell phone and whatnot, but I don't want it. Okay. So here we have the typical structure of a conditional statement. We come in here, one path to come in, and at some point we have to decide which way to go. One side is labeled true, the other side is labeled false, and here we have a condition that will either return true or false depending on the state of the variables. In this case, we have x is greater than y being the condition. And then on the true branch, which means everything between the then and the else is the true branch. In this case, we have z getting the value of x. The other branch is getting z is getting the value of y, and that's it. Are there any questions about this picture? How we are representing a conditional statement in a picture, in a diagram? No questions? Okay. So now we want to figure out the pre and post conditions of everything. Have we seen that code already? I mean, that looks vaguely familiar. That's the pseudocode to do what? Or what do I claim that it will do? Figure out the maximum. Exactly. Okay. So I claimed, before this class, like about 2 or 3 weeks ago, I presented this code in the context of explaining conditional statements. And at the time, I claimed, I did not prove, I just claimed that this code will figure out which one of x and y is the maximum or both, and make sure that z is the maximum of the two variables. Do you guys do kind of remember that part?
Yeah.
Okay, very good. And at the time, I did a few traces. Okay, I said, what if x is 1 and y is 2? What if y is 1 and x is also 1? Okay, not exactly those examples, but I illustrated a few test cases. And in all test cases, the algorithm seemed to work just fine. Right? The next question is, how many test cases do I need to make sure that this algorithm is going to work? I can put it through like 50,000 test cases, and it all worked. And then the next test case I put it through will prove that it is not working all the time, right? Because it is an empirical testing method. I can only show that with all the test cases that I have fed it, it works. But with a test case that I have not presented it, exposed the algorithm to, maybe that one will break it. There's no guarantee that it will work for the next test case. Are you guys convinced about that? Now, obviously, this is a very simple algorithm, and most people will look at this code and say, intuitively, it has to work. Okay? But what if you have a program that is slightly more complex? Then you cannot just look at it intuitively and say, oh, it's going to work. There's no way you can just look at an algorithm and say that. So what I want to do is to have a method and say, I know this is going to work because I can mathematically prove it step by step. If I start with a certain assumption before line 1, by the time I get to post 5, I know post 5 has to specify that z is the maximum of x and y. I want to be able to do that because I'm lazy. Okay, I don't want to come up with 65,000 test cases to only get the relative confidence that it will probably work for the next test case. I want to prove that it is working once and for all, so I don't have to spend the time to come up with test cases. Does it make sense? Okay, so that's what we're going to do here. The assumption of line 1 is I don't want to say anything about x, y, or z. In other words, I want to say, I want to prove this algorithm will work regardless of the value of x, the value of y, and the value of z before it gets started. I don't want to place any restrictions like x has to be positive, y has to be negative, or anything along that line. I don't want to put any restrictions whatsoever on the variables so that I can get to when I get to the final solution, it proves that it will work regardless of what value of x and y and z you throw at the algorithm. What is the simplest condition that says regardless of the values of all the variables, it is going to be true? True. Just true itself, right? True is true, and it is the simplest one. Very good. So that's why the precondition of line 1 is simply true, saying that I'm not making any assumptions. Okay, I'm just saying that I know nothing about x, I know nothing about y, I know nothing about z, or how they relate to each other. If I start with these assumptions, or this one, basically no assumption, and I can still prove the algorithm works, guess what? It has to work, right? Okay, so in the picture, which is not going to be captured in the notes, so if you want the picture, you have to draw it on a piece of paper or borrow it from somebody. This is our pre-1, and I claim that it is just true. I don't want to deal with post-1 because post-1 is really kind of confusing. Am I talking about before line 2, or am I talking about before line 4? Because post-1 is kind of hard to define. So what I would do is this part here is known as pre-2. Okay, whatever I know prior to the execution of line 2 is pre-2. Whatever I know before line 4 executes is what I would call pre-4. Is that okay? I avoid the use of post-1 altogether because it is ambiguous. Okay, so looking at this picture, can we say something about pre-2? What do we know before line 2 executes? In other words, I know that I took this branch. I know that I'm about to update z with the value of x. What do I know prior to line 2? That's the question. Okay, but technically speaking, I will start with this. I will say that whatever is in pre-1 is still true. And on top of that, the condition of the conditional statement is also going to be true. Now, it seems kind of weird. How do I know for sure that pre-1 is still true at this point? Did I have a chance to change anything? No. Evaluating the condition does not change anything. Okay, all it's doing is to check this value, check the value, see whether the greater than relationship is true or not. But I don't have a chance, I did not have a chance to change x, I did not have a chance to change y, which basically means whatever I knew about the variables has still got to be true at this point, even though now I know a little bit more. I know that x is greater than y if I'm here about to execute the statement on line 2. Is that making any sense? Okay. And it is very important from your perspective to also write it the same way, to state pre-1 and x is greater than y, even though in this case it is trivial. In this case, I call it trivial because pre-1